morning. Morning. I hope you've had a nice morning so far, and I hope you're ready to join us in the first of 3 complementary sessions on fractions, decimals, and percentages. I myself am going to really hang on to these and watch these, and I might have to watch them back because this has been my downfall in my career with maths, and I'm really looking forward to some innovative ways to help myself get more in tune with what you need to be able to do. So again, thank you for coming along this morning, and I'm delighted to see so many of you back that have been to some of our earlier sessions, but also some new folks who are obviously tuning in as their children are a wee bit older into second level and are at the stage that they're learning this in school. I'm a parent myself, and I know how hard it can be to support your children in their learning, particularly as they get older and the techniques they're using become a little bit more complicated and a little bit more out of your reach in how you explain them to your children. So I'd like to thank, on behalf of the National Parent Forum of Scotland, Chris McKenna from Counting Us, who puts on these sessions for us, and just to thank him for his involvement, his engagement over the last few weeks. Counting Us has been into many local schools and many local authorities. So as you know, some of your children will have maybe engaged with him before, or actually be using some of the techniques he promotes in your school setting already. And so before I hand over to Chris, I'd just like to say that at the NPFS we're having a busy time at the moment, and I'd like to get you to ask you if you'd try and keep informed with us from now and over the summer holidays. We'll be sending out we'll be sending out newsletters from our website, with social media. We've got lots of events planned for over the summer holidays, and a big event on tonight, a Q&A with the Deputy First Minister. If you want to look to our social media, you can still join up. There's spaces to join up this evening if you want any of your questions on blended learning and how the back to school. But now to go over some of the housekeeping for today, more importantly. Our social media is on, and we would love you to tweet pictures of your children enjoying maths. Our hashtag is #NPFSmaths. So I'd like to see all those tweets. But the housekeeping is everyone will be muted as usual. The cameras will be switched off apart from Chris during the session. If you've got a question, go as usual through the chat function. Chris will answer questions as he goes on, and if it's not possible, some of our team will answer them as they go along, and we'll try and get back to you if it's something a bit more complicated that we can't answer right there and then. Try and, as you say, be respectful in your comments. There are children participating with their parents, and so I'd ask you to do that and to be mindful of that. So just to remind you that you'll get a survey after the event, which I hope you'll fill in. It's really, really beneficial to us in the NPFS to understand what's important to you as parents, and what you feel are the best bits, and what you think we could maybe improve on a little bit. I'm quite sure we couldn't really improve on much. Chris is great. So, but we want you to get as much out of these sessions as possible. So I hope you enjoy yourself this morning, and hopefully see you during the week to the remainder parts of these 3 complementary sessions. So I'll now turn over to Chris and Austin, his son, and let you go on with the fun part of the maths.
Hello everyone, welcome again to our 4th session, and our first one on fractions, decimals and percentages. We've got the helpful Austin back with us again today. So one thing I just want to say is, well, I've not done this yet, but in the chat box, can you just let us know where you're all from? So if you're from Aberdeen or Glasgow or Dundee or Edinburgh, whatever it is, and what part of Scotland you're joining us from, just to see exactly what the geographical spread is like. Okay, right, so we're going to get started. Today we're going to focus on fractions. So 3-part series are going to focus on fractions, decimals, percentages. So today the focus is going to be fractions. So I'm going to start by sharing my screen with you. So hopefully we have pen, paper, and we are ready to shout out the answers. We're ready to type the answers into the screen this morning, okay? So obviously fractions, decimals, percentages is a huge area in math topics. It goes all the way through. So what we're going to cover in the next 3 sessions is just going to be kind of bit parts of it, but it's the parts that I think are the most crucial and the most fundamental to understanding everything. So again, let's use the hashtag NPFS maths if you are putting out tweets, and let's get pictures of you, your children working together and see what impact this is having in the learning at home adventure. Okay, so these are the things we're going to cover. What is a fraction? We're going to cover fraction sizes, equivalent fractions, fractions of a quantity, ordering fractions, and if we get time at the end, we'll look at what fraction is bigger using a half as a benchmark. If we don't get time, the slides will be on my website at the end, so you can look at this anyway. And again, the slides will be on this website here, www.countonus.org.uk/learning-together. I'll put that on again at the end. There'll also be tasks for us to do today as well. So what is a fraction? Well, I'm going to start with a block here. So this block represents one whole. And what I'm going to do to that block, I'm going to cut it up into 2 parts. Do you see I've got 2 parts? One part is green. So say one part is shaded out of the 2 total parts. How do we write that as a fraction? We'll write that as 1 out of 2, or some of you might know that as a half. Now, this bottom number is called the denominator, and that tells me the number of equal parts the whole is cut into. So I've cut this fraction or this block into 2 parts. So therefore, 2 is the denominator, that's what goes on the bottom, the number of equal parts. 1 is the focus part we're talking about. So we're talking about what fraction is shaded. So that's called the numerator, and that's the number of parts of the fraction we're focusing on. So we're focusing on the shaded part. So we can see what fraction is shaded. It's 1 part out of the 2 total parts. So it's a half. We call that fraction a half. If we look at another fraction block here, this time I'm going to cut it up into 4 sections. I'm going to shade one of the 4 sections again. So I say 1 part is shaded out of the 4 total parts. What fraction is shaded? Well, it's 1 out of the 4. We call that a quarter. The denominator again is the number of equal parts the whole is cut into, and the numerator is the number of parts of the fraction we're focused on. So we're focusing on the shaded part here. Any questions about anything, you type them into the chat box, and I will be forwarded some key questions on my mobile to answer. Okay, here we go. Next part. So I want you to answer at home, what fraction is green? So think at home, you can write it on your piece of paper, what fraction is green? First of all, how many equal parts are there? How many parts are green? Oscar, can you tell me what fraction is green?
1/5.
1/5. Do you know how you say that fraction, Austin?
No.
No. So that's 1 part out of the 5.
Oh yeah, I do.
How do you say it?
1/5.
1/5, good. And what fraction is red, Austin?
4/5.
Good, it's 4 parts. 4 parts are red out of the 5 total parts. So we can say the answer is 4/5 are red. Good, let's move on to the next one. So what fraction is shaded in this one here, Austin?
1/3.
Good, so we've got 1 part that is green out of the 3 total parts. So it's 1 out of 3, so the answer is 1/3. Let's look at the next question. So we'll give it a chance at home to shout this out. What fraction is shaded here? So look at how many total parts are in this shape. How many parts are shaded? Therefore, what fraction is shaded? Do we have the answer? Are you shouting out at the screen at home? I hope so. Are you writing it on your bit of paper? And the answer is, Austin?
1/4.
1/4, 1 part out of 4. Good, well done. Let's look at the next one. So don't shout out. Let's give it all the chance to get the answer at home. So what fraction is shaded in here? So how many total parts are there? How many parts are shaded? What fraction is shaded? Shout out at home. Do you know the answer? Write it on your bit of paper. Austin, tell us.
2/4.
2/4. So we don't say 2/4. We say it's 2.
Oh, quarters.
2/4. So it's 2 parts out of 4. So we pronounce that as 2/4. Some of you might think that we can say that as a half, and we'll talk about that later on. And here, this one here, again, think about it. What fraction is shaded? So I want you to look at how many total parts are there, how many parts are shaded, answer the question, what fraction is shaded? Do you have an answer at home? Are you shouting out? Are you telling your parents? What is the answer, Austin? Good, it's 4 out of 5, so the answer is 4/5. Now, the good thing is, well, I've got some activities and tasks for you to do at this website. If you type in that web address, www.countonus.org.uk/learning-together, this will pop up. You scroll down to session 4 and hit that tasks button there, and you'll get lots of exercises for you to try. But I want you to do that after the session, after this live video on fractions. Okay, let's go on to the next part. So here, we don't need to use images all the time. You could use counters. You could find some counters on your desk, or you could use a pasta shell, something at home that you can physically move around and say, okay, what fraction are yellow here? I might want to organize them together and say, okay, I could put them like that, or I could put them like that. But whichever way we look at them, what fraction are yellow? How many cubes are there all together, Austin?
5.
5. How many are yellow?
3.
So what fraction is yellow?
3/5.
Good, 3/5. So we pronounce that as 3/5. Good. Okay, look at this next question. What fraction is yellow this time? Do you know the answer, Austin?
Yes.
Do you know the answer at home? Have you written it down? Are you shouting it out? Doesn't matter. Don't think you look silly just because you're shouting things out at home. This is part of the fun. What's the answer, Austin?
1/5.
Good, the answer is 1/5. So here is just how we pronounce all the fractions. So 1 out of 2 is 1/2. Then we've got 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9. So that's how we pronounce all the fractions. Again, these slides, you'll be able to download these slides after the session here. And finally, 1/10. So here's a good question to ask. What is bigger, 1/4 or 1/3? So what I want you to do is I want you to draw 2 blocks the same size, or 2 bars or 2 rectangles the same size, right beside each other, above one another. So draw 2 blocks out like that, 2 bars or 2 rectangles, and we're going to see what is bigger, 1/4 or 1/3. So the top bar, or the top rectangle, I want you to cut up into 4. So can you cut the first of the top rectangle into 4 equal parts, or cut up into quarters? And what I want you to do is just quickly shade 1/4 or shade 1 part out of 4. Then the bottom one, I want you to cut it up into 3 equal parts, or I want you to cut up into thirds, and I want you to shade 1/3. Now you might know the answer already. What is bigger, a quarter or a third? You might be able to see that straight away. But I want you to focus. I want you to shade a quarter in the top part and shade a third in the bottom one. And we can see that we started with 2 blocks that were exactly the same size. We cut one into quarters and shaded 1/4. We cut the bottom one into thirds and shaded 1/3. And we can see here that a third is bigger than a quarter. Would you agree, Austin?
Yeah.
Yes. So 1/3 is bigger than 1/4. We got that? Yes, good. Okay. Now also I can look at a fraction wall here and say, okay, right, what we have up at the top here is we have 1 whole. And what I've done in the second row is I've cut the 1 whole into 2 equal halves. So here, there is the size of 1/2. Then I've cut the third one into thirds, then into quarters, then into fifths. And I can see, look at all the relative sizes of all the fractions. So we can see here that a half is bigger than a third is bigger than a quarter is bigger than a fifth. And I could keep going. A half, a third, a quarter, a fifth, a sixth, a seventh, an eighth, a ninth, and let's see what that looks like. So we can see here, yep, a half is bigger than a third, so on, and so on, so on, so on. An eighth is bigger than a ninth is bigger than a tenth. But here are some key questions. Look at the relative sizes of all the fractions. Look at the size of 1/2 compared to 1/3. We can see here this arrow This red arrow, double arrow, tells us or shows us the difference of the size of a half compared to a third. But if we look at the size of a ninth compared to a tenth, it's a very, very, very small gap. A ninth is bigger than a tenth, but not by much. Whereas if we look at half, how much is a half bigger than a third? It's quite a big bit bigger than a half than a third. Whereas down here, it's getting much closer together. So the bigger the denominator, the smaller the size of the fraction. And I've got a question to ask you now. What do you think is bigger, 1/20th or 1/12th? So look at this as a guide. A quarter's bigger than a fifth. A fifth is bigger than a sixth. A sixth is bigger than a seventh. A seventh's bigger than an eighth. An eighth's bigger than a ninth. A ninth's bigger than a tenth. What do you think is bigger, a 20th or 1/12th? Do you have an answer, Austin?
1/12.
Good. 1/12th is bigger than 1/20th. As because the bigger the denominator, the smaller the size of the fraction. Okay, I'm just going to quickly stop here and see if there's any questions coming through for me to answer. It doesn't look like it, so if you have any questions, please type them into the chat box, and I, myself or Austin, will do our best to answer these questions. Okay, I'm going to move on now. Okay, so ordering fractions. Now, what fractions are just numbers, and we can put them on the number line. So, where do you think a half would go on the number line, Austin?
Right in the middle.
Right in the middle. Good. Now, we could draw another number line, and this time we're going to put thirds on. So, I'm going to put a third on and 2/3 on. So, again, I'm thinking of cutting the shape into 3. So, here, a third would go there, and 2/3 would go there. You with me? Now, I'm going to draw another number line, so 0, 1, and this time I'm going to put quarters. So, I'm chopping the line into 4 sections, a bit like earlier on when we shaded a quarter, we cut the bar into, or the rectangle into 4 sections. So here I'm just going to think of the same kind of technique or same strategy and put quarters along the number line. So here I'd have 1/4, 2/4, again, which would match in with where the half should go, because 2/4 is the same as a half. We'll talk about that more later on. And here's 3/4. So there's, I'm putting the fractions onto the number line between 0 and 1 to show their relative size. And finally, what I'm going to do is going to put fifths along the number line here. So I've got 0 to 1, and I've got 1/5, 2/5, 3/5, 4/5. So again, my fifth, we're chopping it into 5 bits. So we're thinking this number line we chopped into 5 bits. So there's 1/5, there's 2/5, there's 3/5, there's 4/5. And what I can do now is I can try and move all of these onto the 1 number line. So put my half up there, and I've now got my third and my 2/3 along the same number line as my half. I'm going to move a quarter up here, 2/4 up here. Again, we can see that's tying exactly in with a half. I'll slide 3/4 up here. So then I've got my halves, my quarters, my thirds on the same number line. Now I'm going to bring my fifths up. 1/5 goes there, 2/5 goes there, 3/5 goes there, and 4/5 goes there. So we can see the relative sizes of all the fractions between 0 and 1 there. Not all the fractions, but these key ones we're talking about here. And that is the size of the fractions. They are just numbers, and we can put them on the number line. So that's something I would get really familiar with, putting these fractions, key fractions, a half, a third, 2/3, 3/4, and so on, fifths, onto the number line to understand where they sit in the relative size compared to 0 and 1. I'm just going to quickly check my message, see if there's any questions about that there. Are we all okay? Are we having fun? Let's type into the chat box if we're enjoying this session, and any questions you want to ask, please let us know. A really key topic, fractions. If you can understand fractions, then it opens up a lot more scope for subjects later on in secondary school and so on. Okay, how much is shaded here? Look at this shape. How much have I shaded? Can you tell me, Austin?
1/4.
1/4. What fraction is shaded in this other one?
1/4.
1/4. What fraction is shaded up here?
1/4.
1/4. What fraction is shaded here?
1/4.
So we can look at all the different ways I can shade 1/4. So I can do it vertically. Sorry, yep, vertically like that. I can do it horizontally. I can cut the flag into like a cross. I can do one section.
A plus sign.
Or a plus sign, yep. And here I'm kind of in that odd type shape, but it's still 1/4. So we can see all of these fractions, all of these sheet areas are exactly the same size. I'm just checking, I think I might have a message coming through here. Good, the feedback's coming through saying great, fun learning, brilliant, that's what we like to hear. Please let us know how everything's going. We like to hear comments, we like to know what impact this is having. There is a huge big team behind orchestrating all these sessions, and we like to hear the feedback, positive or negative. Please, if you think we can make it better, let us know, because we want to make this really, really purposeful and have an impact for you guys at home. So yeah, 1/4 here we can see here, all of these fractions are all these sheets are the same size, are all 1/4 of the shape, which brings us on nicely to equivalent fractions. So equivalent fraction, what does that mean? It means equal fractions, or it means fractions that are the same. So what I want you to draw, can you draw me a rectangle? If you've got square paper, draw 4 by 3, like so. So draw a rectangle like that, 4 by 3. How many boxes are inside that rectangle? Austin?
12.
12. Okay. What I want you guys now to do at home is, can you put 4 dots in the 4 top rows, in the 4 squares at the top row, please? So we have 4 dots in here. Now the question is, what fraction of the squares has dots? So how many dots are there?
4.
How many squares are inside the red rectangle?
12.
So we can say out of the 12 squares, 4 of them have got a dot. So we can write 4 out of 12 have dots, yeah? So that, do you know how to pronounce that, Alison?
4/12.
Good, 4/12. So 4/12 of the squares have got a dot. But we can also see that I've added 2 lines in. So now I can see, look, I've got 3 rows. I've got the top row, I've got the middle row, and I've got the bottom row. Does the top row have dots? Yes or no? Yes, it does. Does the middle row have dots? No. Does the bottom row have dots, Austin?
No.
How many rows have got dots?
1.
How many rows are there?
3.
So we can say another way to describe the dots is 1 row has dots out of the 3 rows. So we can say that's equal to 1/3. So another way to describe the dots is 1/3 of the shape has dots. So 4/12 we can say is equal to 1/3, or the word we use when we're talking about fractions is
Equivalent.
good, equivalent. So 4/12 is equivalent to 1/3. Do you have that at home? Let's record that. 4/12 equals 1/3, or 4/12 is equivalent to 1/3. And the good thing is we can make progress here. We can go further. We can say, okay, let's put another 4 dots in there. So let's do that on your shape. Draw in another 4 dots. And the question is, how many dots are there now? Austin? 8 dots. How many squares are there altogether?
12.
Still 12. So now we can say out of the 12 squares, 8 of them have got a dot. So 8 out of 12, or 8/12 of a dot. How many rows have got dots? Think about that at home. Does the top row have dots? Does the middle row have dots? Does the bottom row have dots? How many rows have got dots? How many rows are there altogether? So what fraction have got dots now, Austin? If you think of the rows, can you tell us?
2 out of 3 rows.
Which is, what fraction is that?
2/3.
Good, 2/3, well done. So we can say that's 2 out of 3, which equals 2/3. Okay, so we can say 8/12 is equivalent to 2/3. And we're obviously using this visual clue here to help us, but it's important that we record our findings over here. So it's important that we write down 8/12 equals 2/3. And let's look at, what if I put in another 4 dots? How many dots do I have now? Shout it out at home. How many dots do we have at home? Sorry, how many dots do we have on the screen? The answer is 12 dots out of 12. So we can say 12/12 have got dots, which equals how many rows have got dots now? 3, so it's equal to 3/3. How many shapes did we draw at the start?
1.
I've started with one shape. Now that one whole shape is covered in dots. So 12 twelfths equals 3/3, which equals the one whole shape that we started with. Do we get that? Do we understand that? Is there any questions? I'm going to quickly just stop and check, see if we have any. No questions coming through at the moment, so that's fine. If you have any questions, let us know. Now, a really nice thing I like to point out here is, obviously, you don't have to draw dots. You can just curl, shade the shape in yellow, then blue, and then red, and that shows you the same thing. So you don't have to draw dots. You can just shade all the squares in. But this is a small part of a table square. So here we have the 1 times table, the 2 times table, and the 3 times table. Now, why am I showing you that? Because if I highlight the 1 times table and the 3 times table, and if I go to anywhere on the 1 times table, like say 4, and go to the same position on the 3 times table, we can see that 1/3 is equal to 4 twelfths. You seen that before, Austin? Austin's got the goldfish face here. He's surprised. Have you not seen that before, Austin? No?
Yeah.
So, a really interesting thing, we're going to focus more on this later. So, also if I look at the 2 times table and the 3 times table, so I'm highlighting 2/3 here. And if I focus on, again, the 8, and I focus on this right at the same position in the 3 times table, we can see 2/3 is equivalent to 8 twelfths. So the times tables can be, table square can be used to highlight equivalent fractions as well. Impressed, Austin? Oh, that's one I've not taught him that one before. Okay, let's look at the big grid again. So can you highlight this shape? So draw me this shape on the big grid. If you don't have square paper, just try and quickly sketch that out. So we have a shape which measures 4 by 5. So 4 along and then 5 down. Quickly draw that out for me. We're going to look at more equivalent fractions. So we've got a wee comment coming through. For once, I'm getting it. Karen Forbes. Brilliant, great session. Thanks, Austin, for helping. There you go, Austin. You're getting some special thanks messages on the chat box. Right, okay, so how many squares do we have in here then, Austin?
20.
20. What I want you to do at home is put 4 dots in the top row. Okay, so put 4 dots in the top row. How many dots do we have, Austin?
4.
Out of how many squares?
20.
So we have 4/20ths that I've got a dot, yeah? But as you can see, I put black lines down here to show the rows. So I've got first row, second row, third row, fourth row, fifth row. How many rows have got dots?
1.
1 in the top row. How many rows are there?
5.
So we can describe the dots as being 4 out of the 20 squares or 1 row out of the 5. So we can say 4/20ths equals
1/5.
or is equivalent to 1/5 is the word we use. So 4/20ths is equivalent to 1/5. I can then add an extra 4 dots in. So do that at home. 1, 2, 3, add an extra 4 dots in. Go, go, go. And let's see, okay, how many dots do we have now? How many dots do we have now, Austin?
8.
8 out of
20.
20. Yep, you're right. 8 out of 20, which, how many rows is that? So let's think at home, how many rows have got dots now? We can see it's the top row and the second row. So it's, how many rows, Austin?
2.
2 rows out of
5.
5 rows altogether. So 8/20ths is equivalent to 2/5. Do you know what I'm going to do next, Austin?
Add another row of dots in.
I'm going to add another row of dots in. So let's add another 4 dots in there then. How many dots are we at now then? Shout it out at home. How many dots are we at now? How many, Austin?
12.
12 out of
20.
So 12 out of 20. How many rows is that, Austin?
3 out of 5.
Which is what fraction is that again?
3/5.
So 12/20ths is equivalent to 3/5. How are we getting on with this at home? Are we keeping up? Yeah? make sure we're writing these equivalent fractions down. So 4/20 equals 1/5, 8/20 equals 2/5, 12/20 equals 3/5, and so on. And then we can add another row of dots. So how at home, tell me how many dots are on in this shape now. Do you know? It is 16 dots out of 20, so it's 16/20 of the squares have got dots, which is equal to how many rows is that? It's 4 rows out of 5 rows, so it's 16/20 equals 4/5. And I can see if I go one more, we can add another 4 dots on, completely fill the squares with dots. So now we can see we've got 20 out of 20, or 20/20, which equals the 5 at the 5 rows, or the 5/5, which is now the one whole shape that we started with. So now the one whole shape that we started with has got dots in it everywhere. So I hope that makes sense. We can try that with any fraction you want. You can think of your own fractions and you can draw the shapes out. You can put dots in the rows and you can see what it is equivalent to, and so on. And anytime you're struggling with fractions, I would always go back and draw these type of things out, draw the picture that will help you understand what it is you're doing. So again, we could focus on, so we're talking about 1/5 here, so I'm going to look at 1/5, and we can see that's equal to, again, if we go to the relative position on the times table, we can see if I highlight 4 and highlight the same column there on the 5, in the 5 times table, we can see 1/5 is equivalent to 4/20. If it was 2/5, highlight 8, highlight 20. 2/5 is equal to 8/20. 3/5, 12/20. 4/5, 16/20. And we can do that for any fraction. So if I look at a half is equivalent to 2/4, or 3/6, or 4/8, or 5/10, or 6/12. And we can see actually, I can go up and down this here, and actually a half is equivalent to 9/18, 10/20, 11/22, 12/24. I don't know if that's the right way to say that. And focus on again, I could look at 1/4 and say 1/4 is equivalent to 2/8, 3/12, 4/16, 5/20. And again, we can see any one of these 8 out of 32, or 9 out of 36, 10/40, and so on, 12/48. I can look at 3/5 and see what is 3/5 equivalent to. It's equivalent to 6/10, 9/15, 12/20, 15/25, 18/30, and so on. So the table square is a really nice way to tie in equivalent fractions. But I would always be drawing my shapes out like we did earlier on with the dots and so on. So anytime you're looking at a shape, I want you to draw the dots. I think that's the best way to learn it. Okay, I'm just going to stop just now and have a wee look at my messages to make sure that if I have any questions coming through. Please ask us some questions. No more questions just now. Oh, there might be a question coming through. I can see someone is typing. So meanwhile, there is a task for you to try. So again, if you go to the website that I put on earlier on, there is a task for you to do. So you have to shade 1/3 of these shapes and then tell me what the equivalent fractions are. So again, if you go to that website there, www.countonus.org.uk/learning-together, and go to that bit, you'll be a task where you can complete that. Good. Right. Next part. Remember, keep putting in, if you're on Twitter, get those photos on Twitter, get the comments on Twitter as well. Hashtag NPFS Maths. Let us know how you're getting on. It's nice to see pictures afterwards. I go onto Twitter and it's nice to see that there's been kids sitting there working away through the maths. So please put them onto Twitter or Facebook or so on, and tag us, Education Scotland Maths, National Parent Forum, and Count on Us, please. Okay. We're going to use the big grid to look at, so now we're going to go into fraction values. Okay, so we're going to find the fraction value of a quantity. So we're going to look at something like half of 20. Now, some people might know what half of 20 is, and you might be shouting the answer out at home, but I want to kind of go through this strategy because I think it will help you with more complex numbers. So half of 20, what I would draw is make a rectangle with 20 boxes, either 4 by 5 or 2 by 10. So I'm going to go 4 by 5. So I'm going to make a rectangle that's got 20 boxes. And what I'm going to do is I'm going to shade half of it yellow. So you can see I've got 20 boxes and I want to shade half of the shape yellow. Have I shaded half of the shape, Austin?
Yes.
How many boxes are yellow?
10.
10. So you can see if I start with a rectangle, it's 20 boxes, and then I shade half of it, I can see that corresponds to 10. So the yellow section is 10 boxes, so half of 20 equals 10. I could also have started with another rectangle. Rather than 4 by 5, I could have started with a 2 by 10. And again, shade half of it, we would get 10 boxes. So what did we effectively do to that 20? We basically divided the 20 into 2 sections, and each section was 10. So this is the kind of more abstract part of it, but this is a nice wee visual way to look at how we're getting the answer. Let's look at another question. Say I want to find. Good, Abigail, saying it's really helping you with our learning, so that is really nice. Thank you for those comments. Anybody else got any comments to add? Even if it's not a question, just let us know how this is going. So we're going to do a quarter of 20. So again, I would draw a shape or a rectangle with 20 boxes. This time I would choose to go for 4 by 5. So I've got 4 times 5, so we know that's 20. So there's my rectangle. At this time, we want to shade a quarter of it yellow. Now, the easiest way for me to shade a quarter is to say, well, I've got it in 4 rows. So if I shade one of the 4 rows, I can shade that top one. If I shaded a quarter yellow, how many boxes is that, Austin?
5.
5. So the yellow section is 5 boxes. Therefore, a quarter of 20 equals 5. And we're doing this in a kind of very visual way here. If you look at this, and again, what we're doing, well, we might eventually say, well, the shortcut here, or the rule that we're going to apply is, well, I'm starting with 20 boxes, I've divided it into 4 sections, and each section has got 5 in it. So 20 divided 4 equals 5. What if it was 3/4 of 20? Well, I'll start with my rectangle, it's 20 boxes again. This time, I want to shade 3/4 of it yellow. So the easiest way I can see to shade 3/4 will be to shade 3 out of the 4 rows. So let's do that. There's 1 row, 2 row, 3 row. We've shaded 3 out of the 4 rows. Would you agree, Oz?
Yeah.
Yes. How many boxes are that are yellow then?
15.
You can see the top one's 5, second one's 5, third row's 5, so it's 5 plus 5 plus 5, so the answer is 15. So 3/4 of 20 equals 15. But what did I do there? I basically split it up into 4 sections, so I divided the 20 into 4 sections. And how many sections did I highlight? I highlighted 3. So what we're doing is we're doing 20 divided by 4 times by 3. 20 divided by 4 got me 5 in each section, and there were 3 sections that were 5. So therefore the answer is 15. So again, this is the pictorial way here. Look at that, but then I'm trying to establish or link to the kind of the pattern that we're seeing, I suppose, and establishing a kind of a rule. Okay, what if it was 1/10 of 30? So I'm going to draw a rectangle with 30 boxes. The easiest way for me to do that is to do 3 by 10. Now I want to shade 1/10 of it yellow. So it's quite easy to look at this because I can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So if I shade 1 out of the 10 columns, so I shade the first one, I've shaded 1 out of 10 columns. Yes?
Yeah.
How many boxes are in there?
3.
3. So I can see the yellow section is 3 boxes. So 1/10 of 30 equals 3. Or what did I do to the 30? I chopped it up into 10 sections. So 30 divided into 10 gives me that there is 3 in each section. So again, this is establishing the rule from the picture. And let's try another one. Say I want to look at 3/10 of 40. So first thing I'm going to do is, oops, just going to fix that. That's make a rectangle, not 30 boxes, of 40 boxes. Sorry, give me a second just to fix that PowerPoint now. There's a wee mistake in it. 2 minutes, guys. Right. Here we go. I've just edited that very quickly. So, the question was 3/10 of 40. So we'd make a rectangle with 40 boxes, so make it 4 by 10. And this time I want you to shade 3/10 of it yellow. So out of the 10 columns, I want you to shade 3 out of the 10 yellow. So hopefully you're doing this at home. We've gone a bit quick here, but shade 3 out of the 10 yellow. So we're looking to find 3/10 of 40. So we draw a shape which has got 40 boxes. I did mine this way. And now shade 3 out of the 10 columns yellow. You should get 1, 2, 3 sections or 3 columns yellow, 3 out of the 10 yellow, which means there's 4 boxes here, 4 boxes here, 4 boxes here. So 4 plus 4 plus 4 is
12.
12. We can see the yellow section is 12 boxes. So 3/10 of 40 equals 12. Or again, you can think, well, I started with 40, I divided it into 10, and then I times that by 3. So again, here is my rule that you might want to establish long term. And I'm just going to stop just now just to make sure we're on track. There's no questions coming through. We're almost finished, guys. I hope you're enjoying this. Hopefully this will help you understand fractions more and be able to go on and tackle fractions problems with more confidence. So 3/5 of 40, make a rectangle this time with 40 boxes. This time I'm choosing to do it 8 by 5 or 5 by 8. So here I've got my rectangle which measures 5 by 8, which is 40 boxes in there. And this time I'm going to shade 3/5 of it yellow. So I can see I've got 1 column, 2 columns, 3 columns, 4 columns, 5 columns, and I want to shade 3 out of the 5 of them yellow. So let's do that. So shade the first one, second one, third one. 8 boxes in here yellow, 8 boxes in here yellow, 8 boxes in here yellow. 8 plus 8 plus 8 equals, Austin. Let's hear people shouting out at home. How many yellows are there? Do we know? Does Austin know?
24.
24. So there are 24 yellow boxes. Therefore, 3/5 of 40 equals 24. So what did we do? We divided the 40 into 5 sections. We shaded 3 of them. So 40 divide 5, times it by 3, we get 24. Now, there are tasks, exactly like it says down here, find a quarter of 8. So you can draw the picture, you can draw a rectangle, 8 boxes, and shade 1/4 of it, and so on with the rest of them. Again, that's that link there, and you go to the button that says tasks. The slides will also be over here if you want to look at these slides we're looking at right now. And there'll be a link to the YouTube video later on as this is being recorded. Okay, last task we're going to look at here, I think, is basically put these fractions in order of size, smallest to biggest. So we've got 2/3, we've got 1/12, and we've got 3/7. So I want you to put these in fractions in order of smallest to the biggest. So what I want you to do is draw 3 bars out for me. Oops. Draw 3 bars out for me. And what I want you to do is I want you to shade the top one with 2/3. Shade the other one with 1/12 and shade this one with 3/7. Got a question come through, I'll answer that in a minute from Nikki. I'll answer that in a second. So can you shade, in this bar shade 2/3, in this bar shade 1/12, and in this bar shade 3/7? Now, it doesn't have to be exact, I just want you to get a rough idea of what we're talking about, and this will help us understand the size of the fractions, smallest to biggest. So I've shaded one of these fractions 1/12, I've shaded the other one 3/7, I've shaded another one 2/3. Which one do you think represents 2/3? The top one, the middle one, or the bottom one? So out of these shapes, one of them represents 1 out of 12 being shaded, one of them represents 2 out of 3 being shaded, and the other one represents 3 out of 7 being shaded. Which bar do you think represents 2/3? Top, middle, or bottom? So write in the answer box, what fraction do you think, or which bar do you think represents 2/3? Top, middle, or bottom? Write the answers in the comment box. Let me know what you think. Austin, what do you think? So which one of these do you think represents 2/3? Top one, the middle one, or the bottom one?
Bottom one.
Austin said the bottom one. Do you think he's right? Yes, he is. That's 1/12, that's 3/7, and that's 2/3. And I can show you that in more detail. You can see here, I've actually chopped them into 12, so we can see here exactly the size of each fraction. So that's why shading is an important task, because it lets me see the size of each fraction. So if I have to put these in order of size, 1/12 is the smallest, 3/7, and then 2/3. Right, somebody asked me a question, do you always divide before the multiplication? Yes, and I'll show you, basically if I go back a few slides, sorry. Yeah, if this question here, it's this question from Nikki, 40 divide 5 times 3, yes, I would always divide first, because that's what you do when you're finding, like, if I go back a few, oops, I went too far, sorry. So like in this question here, Nikki, so 1/4 of 20, so here I would always divide, so you're dividing by 4, that gets you 5. And then the next one, so you're making the number smaller. So here, so 20 divide 4, that gets me to 5, times 3 is 15. Rather, if I was to do 20 times 3, that would get me 60. Then I'd have to divide by 4. So I always like to try and make the number smaller, so divide first. Yeah, that's always what I would do. Thank you. Hope that answers your question, Nikki. Let us know. Right, one last question before I know we're just kind of running over just slightly bit. It's an important thing I want to talk about. One thing that I like to use is talk about what fraction is bigger, 9/16 or 11/24. So I want you to think, what fraction is bigger, 9/16 or 11/24? So shout out at home, type in an answer in the chat box. 9/16 or 11/24. What do you think's bigger? So it doesn't matter if you're wrong here. I just want you to get an initial thought of what you think is bigger here. So it's not important. I'm not concerned about you being wrong here. I just want to think through what your thought process and quickly what your instinct tells you. Austin, what do you think is bigger, 9/16 or 11/24?
9/16.
9/16, okay. Who agrees with Austin? He thinks it's 9/16. Right, Austin, tell me why then.
Because earlier on you said that if the number is bigger, it's less in fractions, and if the number's smaller, it's bigger in fractions.
Okay. So you're going with the bottom number. Okay. But the top numbers are different as well, aren't they? So here, you're right, Austin. But here is what I would tell you to, or my strategy for this one is, I would use a half as a benchmark, or a half as a guideline, right? So what is a half equivalent to in terms of 16ths? A half is equivalent to 8/16ths, isn't it? What is a half equivalent to in terms of 24ths?
12/24.
12/24. So if I'm using a half as a benchmark here, I can see 9/16ths is bigger than 8/16ths, isn't it? But 11/24ths, I can see that's smaller than 12/24ths. So this is smaller than a half, and this is bigger than a half. So therefore, yes, you are right, 9/16 is it. There's a couple more examples on that, but I'm going to let you read them at your leisure later, as we are now approaching 10 to 11 and we'll need to wrap the session up. So I'm going to just scoot by these ones. See, there's a couple more examples. You can use a quarter as a benchmark as well, but I'll let you do that on your own. So here are slides and resources. It can be found at this link that we mentioned earlier on. There is tasks, lots and lots of tasks for you today. The slides are also there, and there'll be a link on to YouTube once we get it uploaded. Again, if you're on Twitter, let's use this hashtag. Let's get promoting these sessions. Let's get all the parents and children out there hearing about them so they can learn together at home. And if you're on Twitter or Facebook, follow us at Counting Us Ed. We're always willing to help people out with their maths homework or their maths tasks. Give them kind of good strategies they can develop understanding from. And thank you for you guys for tuning in again. I hope you enjoyed it. There is a survey for you to complete again if you go to this, type this into the URL to your webpage, or you can scan this QR code with the camera on your phone. It will take you directly to the link, and you can just complete that on your phone. I will be on here for the next 10 minutes or so, depending on the number of questions. So please ask away. I'll just see if there's any questions coming through, not just now, but please ask away. I'll try and see if I can get the chat up at the same time. Wonder if it'll let me do that.
I think it will.
So I'll need to just end the screen share. So please make sure we are filling out this survey. QR scan thing there. You can scan this into your phone, complete the survey. I know we've completed lots of surveys, but each session is really important to get the feedback. Even if it's minor things we can do better, you can please let us know. We really do. This could be a continuous thing, so we want to know any small things we can do to improve these sessions. Then please give us the feedback. Type that into the address bar or scan this. Okay, we'll just stop the share just now. Oh, I managed to get the chat up. Right. Right, he would say, any questions? I'm reading the chat now. So you're welcome, Leslie Camp. You're welcome, Yvonne. You're welcome, Abigail. You're welcome, Gemma Francis. You're welcome, Rachel Anderson. You're welcome, Sharon. Good. I'm glad, Fiona. That's great. Yeah, next session is on Thursday. That's going to focus on decimals, and Friday's session is going to focus on percentages and how fractions, decimal percentages all link together. Yep, it's a wee bit much for a P2, that session there, Gillian, but hopefully some of the tasks that we did earlier on, the shading ones, that might be suitable for the P2 pupil. That's good, Charlene. Glad P5 girls along with us. But Gillian, you can always watch this session back again in a year or two. It'll still be on the National Parent Forum YouTube site, so hopefully you can go back and tune into it then. You're welcome, Robbie. Thanks, Gillian. Any questions, mathematical ones you want me to go over? Just let us know, and we can do some extra ones. Any other questions you have, we can cover them. Please make sure we're all thank you, Jacqueline. Join the task on the website, Numeracy Blueprint, a great addition for the home learning. Brilliant. Thanks, Peter. So again, just make sure we're we're completing this survey, so I'll put the QR code back on. So scan that with your phone camera. It will take you directly to the survey, or type that into your address bar. And also remember, there's the slides and resources can be found at this link here. And get tagging on Twitter, Education Scotland Maths, National Parent Forum Scotland, count on us, Ed. Let's see pictures, let's see children at home with parents learning together. Make sure, again, just I don't want to bore you, but can you please just make sure we do this survey? Give us the feedback, try and make the sessions better, please. Right, guys, I'm going to sign off in 1 minute. So if you've got anything else to ask, please ask in the next minute. And we're going to leave you. See you all Thursday, 10 o'clock, for the session on decimals. And Friday, 10 o'clock for the session on percentages.